Hi everyone, we're back, and I wanted to actually do a unique video, kind of a separate video on Kroger Vink notation. I know it's something that kind of pops up a lot in material science, and I think that this hopefully will be kind of a very helpful video for you to kind of approach any general Kroger Vink problem, and specifically when we're talking about extrinsic reactions. So let's say I have, let's just say CaO, and I'm going to dope CaO with Ta2O5. So when I write that, remember our Kroger Vink notation. So in our Kroger Vink notation, we have, I'm going to change colors here. We have X location. I'm going to do our Y location here in red. Y. And then we're going to have our Z location here in green. So when I'm writing a reaction, so here, my impurity, this is my impurity. So I'm doping my host, CaO. My host is going to be my red. You're going to see why we're coloring it like this in a second. CaO is my host. So in an extrinsic reaction, we have to think about what can occur, what can be on my X, my script. So what can be on the site now? Well, I can have a Ta, I can have an oxygen, so I can only have my impurity atoms, or I can have a vacancy. That's literally all that can exist on that X site in Kroger Vink notation. Now on the Y site, I can have my Ca, I can have an oxygen, or I can have an interstitial site, because we know where those interstitial sites exist in our crystalline structure. And remember, Z is just I'm going to look at the difference between how do I go from Y to X in terms of the charges there. So that's the notation. And then again, if it's a minus, we're using dash, you're doing the primes. If it's a positive change, when I go from Y to X in terms of charge, I'm doing the dots. And so we'll make that clear. So let's go ahead and let's write a reaction. So whenever I'm doing a defect reaction, I'm always going host. Actually, let's just be consistent. I'm not doing host. I'm going to just erase. I'm going my impurity here, and then my host goes right here. So my host. So that's how we're going to write it. So I'm just going to rewrite this right now. And then I'm just going to write a defect reaction. So I need my Ta2O5. And then I'm going to have a black line. I'm going to say go into my host, which is my red, CaO. And let's say I have to write a cation substitutional. So a cation substitutional defect will be putting a cation on my X site. So again, what can exist on my X? Well, the only cation is Ta. I'm doing a cation substitutional, so I'm substituting a Ta where my other cation should be, which in my red, I think I erased it. The only thing that can exist on my Y are Ca there. So Ca is 2+, tantalum is +5. So now my charge is going to be minus 1, 2, 3. Or excuse me. That's a mistake. Remember, it's going from Y 2+ to 5+, so that's going to be a plus 1, 2, 3. So I have those charges here. Now I can finish off my reaction. So I'm going to do plus. Now that I have a positive, basically reaction here, I want to get rid of my electrical charge first. I want to be electroneutral first. So I'm going to do a vacancy. And I'm going to do a vacancy in my host, because you can see, again, what can only be on the Y. So I'm going to do a vacancy in my Ca, because the charge will be 2+ to 0. Now that's -2. How do I balance that? Well, I'm going to put a 2 here. I'm going to put a 3 here. Now I'm going to do mass balance across my script. What does that mean? So I'm going to check through my script here. So for example, 2 TAs, and we have 2 TAs right here. Vacancies. Vacancies don't add to my mass balance across my script, i.e. my X location. And then finally, 5. So I need 5. Actually, let me erase that because I'm trying to be consistent here. 5. And now I'm going to have an oxygen here. And then I'm also going to just, because I don't want to deal with the charges, I'm just going to swap an oxygen with an oxygen. I can do that. It's okay. And then I'm going to put my charge here, which is going to be an X. So let's look on the bottom now. How many calciums? So am I balanced on the script first? 2 TAs, 5 oxygens, good. What about my subscript? I have 2 CAs here, 3 CAs here, 5 oxygens. So I just need to have 5 right here. That's it. So you see kind of this way again, the only thing that can be on my X script is my impurity atoms, whatever they are, my anion, my cation, and a vacancy. The only thing that can be on my Y are my host atoms, my anion, my cation, and an impurity. And the Z, you just basically switch it out. What if I asked for a cation interstitial? So let's just erase this here. If I wanted to do a cation interstitial, so again, if I want to put a cation there, it can only come from or if I want to do any interstitial, honestly, it has to come from there. So it's on an interstitial site. This is 0. This should be now +5. So 1, 2, 3, 4, 5. Again, I don't want to do that. I want to deal with something that now I need to write a negative reaction. So I can do plus. I'm going to put a vacancy on my calcium site. And that's going to be a -2 charge. So now I'm going to just put my prefixes. I'm going to put a 2 here. I'm going to put a 5 here. And then what else am I going to do? I'm going to go ahead. First I'm going to do plus. I'm going to do my mass balance. Let's mass balance across the script. So I have 2 TAs. Vacancy doesn't count. I need an oxygen. I need a 5. And then I need my oxygen here. And I need my X because there's no change in charge. I mass bounce across the script. How many CAs do I have? How many are there? 5. That's it. I hope that this is like the definitive Kroger Vink, example, because really I think that the key to these problems is really this right here. What can possibly go on the X? It's only these 3 things. What can possibly go on the Y? It's only these 3 things. If you can follow those rules, then I think you're going to be able to solve every problem that Kroger Vink can throw at you. So thank you very much. I hope this is kind of the definitive video that will end all questions to Kroger Vink. No, it's something that you have to practice on, but I have lots of videos that will allow you to do that, and I hope that this has been helpful. Thanks, and I'll see you in the next video. Bye.